Can you code a simple feed-forward neural network for me without using any deep learning packages such as Chaos, PyTorch, etc.? This is the question I asked to one of the candidates in a recent interview, and the guy was looking at me like I have asked something very difficult. Then I told, can you code one neuron of a neural network without using any packages in plain Python? And that also the guy could not answer. Welcome to Unfold Data Science. My name is Aman and I am a data scientist. Here my objective is to make your basics strong as we move into the world of ChatGPT, transformers and whatnot. Nothing becomes more important than the basics. In this video, let's go ahead and try to understand how to code a basic neuron for a neural network. Let's see step by step. So guys, when somebody tells you to code a neural network from scratch, right? What you need to start thinking is how one neuron will work. Okay, and that is what I was expecting that person to think. So let's start thinking first and then we will go and code it in Python. Okay, first of all, if I take one neuron like this, what will be happening inside a neuron? Inside a neuron there will be some inputs coming, right? So for example, this is first input and this could be second input. Okay, so I will just name it x1, I will name it x2. Once these two inputs enter inside the network, right, then what will happen? It will get, before entering inside the neuron, it will get multiplied with a weight. So I'm just multiplying it here for simplicity. Multiplication I'm saying, okay, and I'm also here saying multiplication. Multiplication with what? Multiplication with a weight. So for example, here I will say w1 and here I will say w2, just for simplicity. Once the multiplication happens, right, then there will be a addition happening. So this will be the addition part. And once the addition happens, right, then there will be a activation part. Okay, and then there will be the output. So this is the output y, and this green box that you can see here is nothing but activation. Okay, and here one bias will also come into the picture when the addition is happening. This is the entire story of the neural network. So what is simply happening here is, in if you see in terms of one neuron, right, the simple thing that is happening is x1 gets multiplied with w1 plus x2 gets multiplied with w2 plus bias term comes into picture. All these guys pass through a function, and that this function essentially is called the activation function, and whatever output you get from here, right, that get passed to the next layer, next neuron, whatever you call it, in this case the output. Okay, now it will be very clear to you if we start putting some numbers here. So let's start doing that. I have noted some numbers and then I will go to Python. Imagine guys, imagine your weights are x1 is equal to 3 and x2 is equal to 4. Not the weights, inputs I mean to say. Okay, and imagine that your W1, the first weight, is equal to 0.5 and W2, the second weight, is equal to 0.8. Okay, and imagine your bias is equal to 2. We need only one number for bias. Okay, in the world of neural network, how you will normally see is matrix multiplication happens, basically the dot product. So we are going to do the same thing here. What we are going to do, x1, this x1, right, this will get multiplied with w1, and this x2, right, this will get multiplied with w2, right, and then whatever the sum in that b is going to get added, and everything is going to pass through a sigmoid. So let's do that. So I'm going to say y, which is my output, is equal to sigmoid of, okay, sigmoid of, so in this case, let's say my activation function is sigmoid. Now, if you have some confusion on, I'm using here terms like weights, bias age, activation functions, right? Simply go to YouTube, guys, and search for Unfold Data Science, Unfold Data Science Neural Network, okay? Neural Network. So you will find videos such as basics of neural network, basics of mathematics behind neural network, and many other videos that will make concepts very, very clear to you. Okay, but here I'm using the terminology because I assume most of you are aware of it. Okay, so in sigmoid, what will be the first thing that will go into the picture? X1 into W1, which means 3 into 0.5 basically. Let me write it here. 3 into 0.5. Okay. The second thing that will go inside is 4 into 0.8, right? 4 into 0.8. And third thing that will go inside is 2. So can I say here sigmoid of 1.5 plus 3.2 plus 2? Can I say this? And can I say this y is equal to sigmoid of how much it will be? 3.5 plus 3.2. Can I say 6.7? And sigmoid of 6.7, right? If you go to Google and search sigmoid of 6.5, this number is 0.9987. I have noted in my note just in the interest of time. If you go to Google and if you see the sigmoid curve, right? Sigmoid of 6.7 is normally 0.9987. Okay. So what our objective is, I just showed you this calculation because I want to take the same numbers and I want to reach to 0.9987 in Python. So if I take x1 is equal to 3, x2 is equal to 4, w1 is equal to 0.5, w2 is equal to 0.8, b is equal to 2, then the output I'm going to get is 0.9987, assuming my activation is sigmoid. Let me show you that in Python. I will code it and show you how that is working basically. Okay. So what all things we will need, guys? I'll just write here so that it's very clear. We will need a activation function. Okay. We will need inputs. Okay. We will need bias and we will need matrix multiplication. So let's do that. Okay. First of all, what I'm going to do is I'm going to say def my sigmoid. So I'm going to define a sigmoid function, my own sigmoid basically. So I will use numpy basically. So I can simply say return. Okay. Return what? 1 by 1 plus, so sigmoid formula I'm trying to put here. Okay. np dot exponential of minus x. This is nothing but sigmoid formula. Okay. 1 by 1 plus e to the power minus x. That is what I'm trying to put here. And here I should import numpy as np. Okay. Numpy as np. Now just to test if my code is working fine, right? What I'm going to do is I'm going to just pass the sigmoid of 6.7 and see if the result is as expected. So let me see this. I will code this full thing, but this I'm just testing. Okay. So my sigmoid 6.7 is 0.9987, which is what I expect. So what I'm going to do now is I'm going to define my class. Okay. So I'm going to say class my neuron. Okay. And in this class, what I'm going to do is I'm going to define a constructor first, def double underscore init. Okay. And then you can simply say self weights and bias. Okay. And then what I'm going to do is self dot the usual things, right? Self dot weights is equal to weight. So I'm going to just initialize few things here, and self dot bias is equal to bias. Okay. So whenever I will create an object of this class, right, what should happen is I will supply my weight and biases, and that object's weight and biases will be whatever I supply. Okay. And then I'm going to simply say def feed forward. I'm going to define my actual function here, which will take self, which is the arguments of the constructor, and inputs. So what I will give in inputs is my input values. Okay. So I'm going to say total, and total is equal to, here I will do a dot product. So np dot self dot weights. Okay. And inputs because I want to do w into x1, right? If you remember, plus bias. Okay. Plus self dot bias. Basically, I'm taking whatever I want to supply above. Okay. And then once I have the total, right, I can simply return sigmoid. In my case, it is my sigmoid. So I will take my sigmoid of basically total. Okay. So my function is defined, everything is done. Now what I need to do is I need to just initialize my weights and biases. Okay. So weights, I will say np dot array. Okay. And here what I need to do is I need to supply the same weights that I gave there, if you remember, 0.5, 0.8, and I will give my bias, which is nothing but 2. And I'm going to initialize a class, an object of that class. Neuron is equal to I'm going to initialize an object of this class with some initial values. And what will be my initial values? It will be weight and biases that I have defined here. Okay. Once this is done, right, then I'm going to call that feed forward method on that one. So I will simply go and say x is equal to np.array. This is my input basically. And in this one, I will say 3,4, which is the input we gave there, if you remember. Okay. And then I'm going to simply say print and call that function neuron dot feed forward. Okay. Feed forward of x. Okay. So how this flow is working, let's try to understand, guys. What I have done here, I have simply defined a class my neuron. So whenever I create an object of this class, right, I need to create with some weight and biases that I'm trying to do here in this highlighted line. Once this is done, right, this object can call any method of this class. So one method of this class is feed forward, which takes parameters of self and then inputs, okay, and then does a dot product, okay, and then returns the sigmoid of this. So that is what is happening. I'm calling the method here. If I run entire thing, then I should get 0.9987, which I'm getting here, because as you can see, I have used the same weights 0.5, 0.8. I've used the same input 3, 4. So I'm getting the same output 9987. So if I change my weights, right, I'll be getting a different output here. Okay. So only thing to keep in mind here is when somebody wants to check the basics, right, we have to see what will be the, we have to break it into smaller pieces. For example, I broke it into smaller pieces. One piece is activation function, one piece is Python calculation, another piece is definition of inputs, and another piece is how we will, stitch everything together. Just think like that and try to code. Even if you don't reach 100%, right, 70%, 80% is fine. Okay. And I just want to leave you with one question. Can you code another network? Can you code a full network for me? I'm not telling you to code back propagation. I'm telling you to code the feed forward only. So what I mean to say is, can you take output from here and feed into the next layer? Can you do that for me in the comment section? If you can do that, I'll be really happy to see your inputs. Okay. So that is your homework for you. I'll see you all wherever you are. Stay safe and take care, guys.